In the words of Max Debris, we cannot become what we want to be by remaining what we are. So practice the philosophy of continuous improvement. Get a little bit better every single day.
Now it's
A very good evening to all. I, Charu Gupta, welcome you all to the day 2 of our 5-day international webinar on applications of cognitive computing in modern era, in collaboration with International Centre for Free and Open Source Software, ICFOSS, Government of Kerala. We owe a special thanks to today's guest speaker, Dr. Shivaji Chalaram, Scientist F, International Bilateral Cooperation Division, DST, Ministry of Science and Technology, Government of India. Dr. Shivaji obtained his...
screen.
Yes, sir, your screen is visible. Dr. Shivaji obtained his bachelor's degree in physics in 1984, pursued his MSc in geophysics during 1984 to 1987 at Andhra University, Vishakhapatnam. Dr. Shivaji received his PhD degree by Indian School of Mines, Dhanbad in 92. During the doctoral research, he carried out significant research on performance of various geophysical techniques and estimated the deep crustal discontinuities beneath the central India region from gravity field data. From 1991 to 1997, he worked at Indian Institute of Geomagnetism and performed several geophysical field surveys using resistivity geomagnetic methods for delineating deep geological structures in the Himalayan collision zone. He also designed experiments to monitor electromagnetic precursors to earthquake in Delhi Rohtak Belt. He was honored by Government of Japan with prestigious Science and Technology Agency of Japan STA postdoctoral fellowship at Geological Survey of Japan. Since 1998 onwards, Dr. Shivaji has been working at the Department of Science and Technology, Government of India. He was honored with visiting professor at Institute of Seismology and Volcanology, Hokkaido University, Japan. He was selected as assistant professor at Department of Earth Sciences, Indian Institute of Technology, Bombay in 2003. The Science and Technology Diplomatic Circle in Japan elected him as its co-chair for the period between 2011 to 2015. Currently, he assumed charge as Senior Scientist and Director in DST, Ministry of Science and Technology, Government of India, with the handling in bilateral S&T cooperation with Germany, Sweden, Switzerland, Austria, China, Taiwan, and Bangladesh. Sir, we welcome you. Sir, we welcome you. It's an honor for us to listen to you today. Over to you, sir.
Sir, kindly
Am I
unmute
audible?
yourself.
Sir, am I audible? Dr. Shivaji, am I audible to you? I think again there is a technical glitch. We should all cooperate with him. Thank you for being a wonderful audience.
Sir, are we audible to you? Excuse me, sir, are we audible to you?
Yeah,
Sorry, not audible.
Sir, you can start now. Am I audible to you, sir?
Yes, yes. Hello.
Yeah, hello.
Yes, sir, you are audible now. Please start,
Yeah,
sir.
I'm audible now. Okay, I'll just start it.
Okay, sir, fine.
Yeah, just a minute. So where is the presentation? Yeah. Yeah. So can you see the presentation now?
Yes, sir, it is
Hello.
visible.
Yeah, yeah. Okay, wonderful. So
Please go ahead.
good evening, everybody, and my sincere apologies for all these technical glitches. It's really wonderful to start this again. So what I'm trying to
It's
do in
okay, sir.
this, yeah, it's okay. So in this webinar, what I'm trying to bring you all is that we will go back to the history of science and technology in India, and then I'll also touch upon the recent initiatives by the government of India in the field of science and technology. Before that, so let us see what are great Indian scientific contributions in the ancient India, and little bit history of science and technology I will touch upon in this meeting. You know, we have very great history of science and technology in India. We have great rishis, you know, all have done as early as 3000 BC. Acharya Kapila, he is renowned as the father of cosmology. And then there are several pioneers of aviation technology, who is known as Bharadwaja, Rishi Bharadwaja. And then Rishi Sushruta is the father of plastic surgery. Now we are talking about the plastic surgery and all in the recent modern India. But as early as 600 BC, we used to have this plastic surgery performed by Sushruta and other rishis. And then as far as atomic theory is concerned, we have Kanada, 600 BC, who is renowned as the father of atomic theory in the country, for that matter, in the whole world. And little recently, we have Acharya Chakra, who is also father of medicine, and Patanjali, and all other sages. We have Aryabhatta, 460 AD, and then Varahamihira, astrologer and astronomer. And in view of all these Indian great scientific contributions, recently, thanks to the Prime Minister Narendra Modi, who has actually initiated this great International Yoga Day, which was actually acclaimed by the world global leaders and the citizens across the globe since 21st June 2015 onwards. And considering the importance of this great Indian yoga, we at Department of Science and Technology started Satyam, science and technology for yoga and meditation, where one can submit research proposals and then they will be supported. And we basically want to understand what kind of advantages the so-called yoga will bring to the mankind. And as you know, we have not only in the field of research, we have the great ancient educational institutions established as early as 2,700 years ago, namely the
Dr.
Taxila
Shivaji?
University. Hello?
Yeah, Dr. Shivaji, sorry to interrupt
Yes.
you, sir.
Yeah.
Sir, are you running through the slides?
Yeah, I'm running through the slides.
Okay, because sir, we could only see the first slide.
Oh, is it?
Yeah,
Let's
as the
see.
flow was progressing, we realized that we are. Could
Now,
you
which
please
screen
share
you are
the
now?
PPT again? The first slide, sir.
First slide only you are seeing.
Yes, sir. Can you please share the PPT again? Then this problem will be solved.
Just a moment. Okay, just a moment. Yeah, I'm sharing again.
Okay, sir.
Yeah. Let me see. So, are you seeing the second slide now? Hello.
I could only see the first slide, sir.
No.
History of Science and Technology in India. Have you seen? Okay. So
I think
every
you are restarting. I think you are restarting the presentation. Yes, now we
okay.
can see the history of science and technology in India.
Yeah. Just a minute.
Yeah, this is the slide
And
we could see.
and now it's not moving.
No, sir.
Yeah, it's not moving. So each and every slide you have to share.
Now, sir, we can see the ancient India scientific contribution slide.
Yes. So every slide you have to share it. And now?
Now it's ancient Indian universities.
Okay. Wonderful.
I think
So
now
I
it's
had
okay.
actually, yeah. So can I restart again?
Yeah, sir,
Yeah.
please.
Yes.
Thank you so much,
So
sir.
we had great Indian contributions in the country ever since 3000 BCE, when Acharya Kapila, actually, who is renowned as father of cosmology, has started a lot of cosmological research. And we had a sage called Bharadwaja, pioneer of aviation technology in the country. And then Susruta, who is renowned as a medical plastic surgery and other things they used to perform. And now, most recently, is Acharya Patanjali, who has actually invented the great yoga in the country as early as several years ago. And now, considering the importance of this yoga, we at the Department of Science and Technology also initiated a program called Satyam, Science and Technology for Yoga and Meditation. So through this, basically, we want to understand what kind of benefits the so-called yoga is generating on the human mankind. And now, as far as Indian educational systems are concerned, we used to be pioneer in the educational affairs also as early as 2,700 years ago, namely the Taxila University, and then during the 3rd century, Puspagiri University, and then Vallabhi University, 7th century, and so on and so forth. We also want to revive this great Nalanda University. Everybody knows. Now the government of India is actually trying to revive the whole, or it's really wonderful reviving our ancient educational systems in the country. Now, coming back to the most recent modern kind of educational institutions, we have Sarampur College, which was established in 1818, Roorkee University, 1847, Bombay University, Madras University, Calcutta University, Aligarh Muslim University, and most recently the Allahabad University. And I'm not mentioning other universities because I want to focus more on the the oldest institution in the country during the 19th century, early 19th century. And now we have other research and academic institutions also, like Survey of India. They are almost 200 years old. We have the world first geomagnetic observatories, which was established in southern part of Mumbai, called Alibag, Geological Survey of India, Indian Railways, India Post, Archaeological Survey of India, and we had very ancient India Meteorological Department, Indian Army, and so on and so forth. And now these are the pioneers of modern scientific community. We had the great C.V. Raman here, Aryabhatta, and then Homi Bhabha, and all other pioneers. Some of them are still alive. Professor M.S. Swaminathan, who is actually a pioneer of agricultural scientific affairs in the country. And then we have the Professor C.N.R. Rao, who is also been awarded Bharat Ratna in the country, first scientist to be awarded Bharat Ratna. Yes, actually. And going back to the historical context of modern scientific science and technology in the country, so during the colonial rule itself, the importance of science and technology was actually recognized, and we had several pioneers who have actually made a lot of indigenous efforts to develop the modern science in the country. The fundamental goals of these efforts were the harnessing science and technology for the development in the independent India, and there has been a lot of great support of thinkers and industrialists and scientists and freedom fighters. We used to have the two-pronged development approach came up, one with rapid industrial projects like small dams and modernization of all the sectors, and basically to link up the industry, local industry and agriculture sectors. And the Indian Institute of Science, Bangalore, was actually a classic example where the industrialists have actually supported and established the research and academic institutions like Indian Institute of Science, Bangalore, which is now one of the premier institutes globally, recognized and acclaimed by the world scientific community. Now, since the pre-independence as well as the post-independence era, the people like Pandit Jawaharlal Nehru and all, they had shown a lot of interest in development of the scientific research and tempo in the country. So I would like to bring upon the quote by Pandit Jawaharlal Nehru: "The future belongs to the science and those who makes friends with the science." With this motto, we had actually gone ahead, and our priority was the issue of values and institutional mechanisms, because though we didn't have the IITs and premier institutes like NITs and all now at the time, but slowly we had been able to set up the Indian technologies in the country. And then with the establishment of Council of Scientific and Industrial Research, CSR, which is the national body for applied research, and then there has been a lot of thrust on higher education in the science and technology, engineering, agriculture, and medicine. We also have a parallelly set up established AIS, All India Council for Technical Education, UGC, University Grants Commission, and ICMR, Indian Council for Medical Research, Indian Council for Agriculture Research, and all basically to link them all with the national building and transform the industry, agriculture, and the society. Like we have the financial 5-year plans we used to have, and the every 5-year plan we have the science plan ready, where we used to state the policy statements and science and technology policy statements. The first science and technology policy statement was actually prepared in the 1958, and then 1983 it became technology policy statement, and 2003 science and technology policy statement. And the document had actually brought up several important aspects of science and technology. So there has been 3 major concerns which drove the specific science and technology policies in the country: science for national development, and security, self-reliance, and scientific temper. The most recently, the Indian Science Congress, every year it happens in the month of January, and then Honorable Prime Minister of India, during the 100th Indian Science Congress, actually released the most recent science policy document. The document basically highlights working towards India to be the amongst top 6 global powers in the basic research, to force international alliances and collaborative partnerships based on parity, reciprocity, and science diplomacy to meet the national agenda, including research in the university system. And also highlights the participation in selected international mega science facilities across the globe, and co-development of knowledge in the emerging fields of science and technology. So realizing the importance of these innovations, India Department of Science and Technology has declared the 2010-20 as a decade of innovations, and also established the National Innovation Council. Now, in the recent government of India has Atal Innovation Mission under Niti Aayog. And we have the India's R&D ecosystems. On the left-hand side, we have all the supporting infrastructures like business incubators, technology and science parks, special economic zones, industrial associations, and so on and so forth. On the right side, we have the government-supported departments: Department of Science and Technology, Department of Atomic Energy, and Department of Scientific and Industrial Research. All these things. Only things now we are trying to bring a unified approach and dialogue among the disciplines and across the institutions, all the for the development of the nation. So now I would like to discuss upon the science and technology ecosystems in the country. Basically, these are all the government-supported departments. I put the top red circles, which are Department of Atomic Energy and Department of Space. So due to its strategic importance, these 2 departments are never attached to any Government of India ministry. However, these are always under the control of Prime Minister of India. We have then comes to the Ministry of Science and Technology. Under the Ministry of Science and Technology, we have several departments like Department of Science and Technology, Department of Biotechnology, which is exclusively supporting the biotechnology related research in the country. And we have Ministry of Earth Sciences, which is the most recent entry into the Government of India ministries. Under this ministry, we want to bring all the geoscientific research and educational institutes under the single umbrella. It is still under the process. And we have DSIR, Department of Scientific and Industrial Research, under which the Council of Scientific and Industrial Research is working. CSR has about 38 national research institutes across the disciplines. And we have DRDO under Ministry of Defense, ICAR, which again is a huge Ministry of Agriculture, and then it has several research institutes exclusively in the field of agricultural research. We have Ministry of Health, where ICMR, Indian Council for Medical Research, which has again several research institutions across the country to deal with medical education and research. And we have, this is the DST family, how the Department of Science and Technology will bring will act as a nodal department to bring in all the other ministries into the same single platform. In addition, DST also supports several research institutes under the Department of Science and Technology. We have 25 research institutes which are directly funded by the Department of Science and Technology in almost all the disciplines, and we have the mandate to support the R&D infrastructure, which I will be dealing in the next part of my talk. We also handle technology missions, like we have Nano Science and Technology mission, and we have the Water Technology Initiative. There are several mission mode programs, and time to time we'll be establishing new kind of missions. And we also recently entered into the educational affairs also. We have the Inspire program, Innovation in Science promotion for the Inspired Research. This is a most recent initiative, a flagship program of the Department of Science and Technology, which will be dealt in detail in the next couple of slides. We have very aggressive science and technology international cooperation, where we handle cooperation with more than 45 countries across the globe in the bilateral as well as multilateral mode. We also very actively involve the science and technology related industry and promote industry academia cooperation in the country. We also have several programs to deal with societal aspects. We have S&T society programs, which again I'll deal separately. And most recently, during 2008 to 9, we have established Science and Engineering Research Board to cater to the fundamental research in the country. Whereas the kind of most applied research is being undertaken by the Department of Science and Technology, whereas the SCRB deals with fundamental basic research in the country. This now has become a separate entity under the Department of Science and Technology, which is called SCRB, which is again very popular entity of the Department of Science and Technology. And as far as the distribution of the trained manpower in the country in the field of science and technology is concerned, this slide shows more often than not about 48 to 50% of Indian graduate students are taking up the engineering and technology courses. Whereas when you look at the science education in the field of natural sciences, it's only 30%. So therefore, we at the Department of Science and Technology had actually brought out a document under the Scientific Advisory Council of Prime Minister of India. The report was prepared in 2013, and it has a lot of great expectations that a large number of graduate students in the field of science and technology should be there, and then postgraduate scientists and PhDs, and so on and so forth. This is taking this as a clue how to promote the basic science and education and research in the country. We had actually came up with a very wonderful program called Inspire, Innovation in Science Pursuit for Inspired Research. So through this program, we are actually targeting the very young students at the age of 15 years to 16 years after just completing their matriculation, 10th class. And then we are trying to attract these young talent in the country through this Inspire program in a very systematic kind of way by awarding a large number of the so-called internships and fellowships for the top 1% of the criteria students in the 10th class, and then intermediate and +2 programs, and then several fellowships to the tune of Rs rupees 80,000 per year. And a large number of people are actually tapping these opportunities, and it doesn't stop after intermediate. It also goes beyond degree, post graduation, and then doctoral programs, and then postdoctoral programs also. Even after finishing the postdoctoral programs, we offer about 1,000 faculty positions across the institutions in the country, where he will be the selected candidate will be appointed as adjunct faculty or contract faculty at the our premium institutes like IITs and ISERs. This is called assured career opportunities in research. Through this program, we are trying to bring a lot of students who are actually interested in taking up the basic research in the country. These are basic mandates of the Department of Science and Technology. What is this department is doing? What is its fundamental mandate? So our mandate is basically to prepare policies related to the science and technology and research and development, manpower training, promoting the industrial infrastructural facilities in the country, capacity building, extramural research funding, and also promote innovation and technology development and its demonstration. We have international science and technology cooperation, societal interventions of science and technology, and in addition, we used to have subordinate offices like Survey of India, which is premier mapping agency in the country, and it prepares all the kinds of maps. You might have seen the road maps and other things. Its mandate is to prepare the maps. We have NATMO, National Thematic Mapping Organization, also part of the Department of Science and Technology. We also have, as I mentioned, SCRB, Science and Engineering Research Board. In addition, we also have TDB and Sri Chitra Thirumal Medical Institute of Science and Technology. And we have about 19 knowledge institutions and professional bodies, and we have 3 binational centers also. We have Indo-German Center for Science and Technology. We have Indo-French Center for Science and Technology. We also have Indo-US Science and Technology Forum. So these 3 science and technology binational centers will act as a platform to promote very aggressive bilateral cooperation between these 3 countries. Through these centers also, we give a lot of research funding to encourage the faculty and students to visit these specific countries for their desired research. So these are most recent initiatives by the Department of Science and Technology. We are trying to bring the best brain to the India. It's like a brain gain through these programs. We have, as I mentioned, there is an Inspire program. Under the Inspire program, we have Manak, Million Minds Augmenting National Knowledge. And we have also Nidhi, National Initiative for Development and Harnessing the Innovations. We have Vajra. Through these Vajra fellowships, we want to bring the famous Indian and other researchers to work with our faculty and students for a minimum period of 3 months to 3 years. We are giving very attractive projects and fellowships to the students who are involved in the visiting Vajra fellowship schemes. We also support overseas doctoral fellowships. That means the Indian students can choose any laboratory abroad, overseas laboratory in any country, and the entire expenses will be provided by the Department of Science and Technology, Government of India. Of course, this is very selective and very difficult to due to a lot of competition, very competitive. And once it is through, it will be really wonderful. We also support national postdoctoral fellowship schemes in the country. One can also do the postdoctoral fellowships in India. We give full support. For the very young researchers who have just completed the PhD programs, there is a program called ECR, Early Career Research Awards, where he can get a project, research project, as well as he can draw his own salary out of the project. We also have a very attractive scheme called Kiran, Knowledge Involvement in the Research Advancement through Nurturing. We have officer scheme, augmenting writing skills for articulating research. We have DIA, Distinguished Investigating Award. I will briefly discuss these things in the latter part of my talk. And as you know, every day or alternative day, we read a lot of news on cyber attacks on our establishments like banking establishments or several government establishments. So in order to deal with these kind of threats by the unwanted people, we have launched a program called Interdisciplinary Cyber Physical Systems, ICPS. And Government of India, including the Prime Minister's Office and Niti Aayog, are actually supporting this initiative in a very big way. Under this ICPS program, we have Internet of Things, artificial intelligence, big data, deep learning, robotics, industries, and smart sensors, quantum computing, and a lot of other subsets are available under this Cyber Physical System Program, ICPS. So kindly go through DST website for finer details as far as this ICPS big data initiatives are concerned. And we also, DST also doesn't work independently alone, stand alone, but it also cooperates with other government ministries also. We have a National Supercomputing Mission with DITI, Department of Electronics and Communications, DITI, under the Ministry of Telecommunications. 6 such supercomputing missions are being established. We have Imprint, the program which is basically a collaborative program between Ministry of Human Resource Development and Department of Science and Technology, is also participating in very aggressive way. This is called Impacting Research, Innovation and Technology. So through this, we are again setting up of mega science projects in the country which can deal with education, training, and research for the Indian scientific community. As far as environment and energy is concerned, we have National Mission for Electric Mobility. We are cooperating with Department of Heavy Industries, Government of India, and Transport and Energy jointly. We are also trying to associate with Ministry of Railways. We have already ongoing programs. So there is a program called Uchtar Aviskar Yojana, which basically aims to connect industries to the IITs. So IITs will do a lot of academic research, but this research has to be transformed and applied to the Indian industries. This is what we are doing through this Industry Connect to IITs program. As far as astronomy, high energy physics is concerned, we are actually working with Department of Atomic Energy and ISRO for these this exclusive high energy particle physics and other physical research activities. And under the Mission Innovation Program, where the Department of Biotechnology and Department of Power are actually nodal agencies for this mission innovation. They're doing smart grids and clean energy initiatives under these mission innovations. And we also other national missions like National Mission for Strategic Knowledge on Climate Change. DST is very aggressively working for last decade or so, and we also engage in National Mission for Sustaining the Himalayan Ecosystems. These are the 2 missions out of 8 missions. The DST is fully taking charge of these missions. And technology roadmaps for climate change. We also have an autonomous body called TIFAC, Technology Information Forecasting and Assessment Council, and which has a mandate to work for the technology roadmaps. We also engage in the national priority missions like Swachh Bharat, clean coal technologies for power, and several other things. And we are also very aggressively cooperating with preparing technology roadmaps in the field of solid waste processing with Minister of Urban Development, Digital India, so digital reconstruction of heritage structures, which is very important in the present scenario. And Swachh Bharat is a new mission under the Ministry of Health, and DST is also, as I said, yoga and meditation through our Satyam program. And we have a large number of science and technology outreach programs, which is exclusively flagship programs for the Department of Science and Technology. The first one is the India International Science Festival. Every year we undertake the science festivals, inviting about more than 5,000 children at the level of even 6th standard and 7th to 10th standards. And these people will be very attractively awarded small fellowships to bring and present their small little experimental innovations. And several these people are being awarded very attractive prizes during the science festivals. And we also have National Science Day, commemorating the celebrations for the Professor C.V. Raman, and then which is again the Indian National Science Congress, very mega event of the country. Every year in the first week of January, we celebrate the Indian Science Congress for about a week, and mandatorily the Prime Minister of India, right from its inception, Prime Minister of the country will inaugurate the Science Congress. We also celebrate National Technology Day through DBT and several other agencies. We have Festival of Innovations. We also have National Innovation Foundation, which is actually in the Ahmedabad, fully supported by the Department of Science and Technology. We also have technology summits. We organize these technology summits with other countries in partnership with other developed countries. And we also have the National Science Children's Science Congress also in parallel to the Indian National Science Congress. And the most recent, the Prime Minister of India actually attended the last Indian National Science Congress, whose theme was Science and Technology and Rural Development. The Honorable Prime Minister Modi has given wonderful message during the 107th Indian National Science Congress. This is the kind of India International Science Festivals 2019. There are a lot of, you can see the themes and activities. It's a full 1 week, one week program where it's a kind of great conglomerate and mixture of students, academicians, and NGOs, and several people will participate in this India International Science Festivals. So one can actually look at the DST website for all the finer details and opportunities that are available for the younger students. Most recently, We also launched DD Doordarshan Science TV programs, exclusive India Science channel. These channels are actually telecast from Monday to Saturday from 5 p.m. to 6 p.m. India Science is an internet-based science channel which is available on any internet-enabled device and will offer live and scheduled video on-demand services. We have now I am going to discuss the India's international bilateral science and technology engagements. We have bilateral and multilateral cooperations with more than 85 countries, and exclusively one-to-one cooperation we have with more than 45 countries. And these basically the international cooperation works like it's a kind of complementary where we want to gain something from the other country, we also have to give something to the other country. This is actually the complementary kind of nature the international cooperation has. So under the international cooperation programs, as I mentioned before, we have Indo-French Center for Promotion of Advanced and Scientific Research and Indo-US Science and Technology Forum, Indo-German Science and Technology Center, IGSTC. So all these three bilateral centers are in and around Delhi only. And these are the most focused sectors for the international cooperation. We have engaged with biomedical and healthcare devices and medical informatics, and then clean and green India, renewable energy technologies, and water purification and wastewater management, municipal, industrial, biohazardous waste treatment, energy efficient and covering appliances, industrial processes, green building, clean coal technologies, and so on and so forth. So under these are actually categorized under the different heads where like Make in India, smart cities, which are the government of India's priority sectors. We support all the basic and applied research in these focused, reoriented sectors. And now I'm going to discuss the science diplomacy for international cooperation. We have very aggressive and excited international diplomatic relations with other countries, but at this moment we have the exclusive science and technology wings in our Indian diplomatic missions in other countries. Presently, we have one with Germany, other with Japan, Russia, and United States of America. Like we actually post a very prominent Indian scientific personality as a science counselor whose role is to promote the Indian science and technology in the country of his posting, and then also bring back the science and technology progress of the other country and make it available to the Indian scientific community and academic community. So this is how we work as a diplomatic people. Now I'm going to discuss in detail the various opportunities that are available with Indo-German cooperation. We have DST, a DAD cooperation for personal exchange. Under this DST DAD, we also established Indo-German Center for Sustainable Development at IIT Chennai, Madras. And we have under the DST DFG, German Research Foundation. DFG means German Research Foundation. Under this, we support research projects on basic and thematic areas. Last call was on nano science and technology, and we are trying to start international science research training groups, IRTG. So this is very kind of mega cooperation program wherein The basic goal of this program is to generate about 25 to 30 research PhD students from both India and Germany. So this is a very huge project will be given to two institutes, one in India and other in Germany. We are yet to start this program. I'm going to start very soon, maybe in a couple of months from now. We have DST Alexander Van Humboldt Corporation, where we organize frontiers of engineering workshops for the mid-career scientific community in the country. So alternatively, the workshops are held in India and Germany in the alternative years, and about 35 to 40 mid-level scientific and academic people will be taken to Germany, and vice versa. German scientific community will come to India when the program is organized in India, and similarly 35 to 40 faculty and research groups will go to Germany and discuss across the table on the kind of cooperation they want to develop. We also have DST Lindau meetings. This is a Nobel laureates meeting held every year in a place called Lindau, a small island in Germany, where we want to all the Nobel laureates, about 50 Nobel laureates will come, and about more than 800 students and faculty across the globe will come and to participate in this Legend to the Nobel laureates. So Indian students will actually get a wonderful opportunity to meet and interact with the Nobel laureates during this 5-day Nobel laureates meeting. So since 2001 onwards, the Department of Science and Technology is taking more than 25 to 30 students and make them meet with the Nobel laureates across the globe. We also have DST Max Planck Corporation. Max Planck is a very renowned organization in the Germany, and then it supports with the Department of Science and Technology. And we also established Indo-German Center for Computational Sciences at IIT Delhi, and we are also supporting research projects in partnership with Max Planck Germany. So DST BMBF. BMBF is a counterpart ministry of Germany which deals with research and education in Germany. And we have this is a DST's counterpart ministry. We recently have started civil security, and we have supported major programs on evacuation of during the floods and development of sensors for metros and volunteering and etc. So under this program, we have also established Indo-German Science and Technology Center to facilitate S&T collaborations. Under the DST Helmholtz cooperation, we are yet to start, and it will be very applied kind of activity. Research activities will be launched from both sides. This is the kind of scientific community that will be young and bright students will be taken to participate in the Nobel laureates meeting. Every year, the meeting will start in specified themes like physics, chemistry, and physiology and medicine. The students will have an opportunity to interact with, this is the most recent batch, which is held in Lindau. About 25 Indian students were taken. This is the place venue where the Nobel laureates have interacted with more than 600 students across the globe. So, as I mentioned, India also participates in international mega science projects because India is a rising powerhouse in the science, and India is participating in international mega science programs. Also, India has built its own mega scientific facilities, and DST supports very liberally to make use of these facilities where India DST is a partner. So, for example, we have Large Hadron Collider, which is located in Geneva. It's also called CERN. We have, you might have heard about more than 2 years back, LIGO, Large Laser Interferometry Gravitational Wave Detectors. We also have neutrino experiments at Fermi Labs, Indian beamline facilities in KK, Japan. And in all these, we have DESI in Germany beamline facility. We also participate in Square Kilometre Array Telescope, and very important and very global mega facilities, International Thermonuclear Experimental Reactor. So this is very important because we are trying to replicate the kind of collision reactions that are taking place at the surface of the sun. So there are two kind of nuclear reactions will take. One is fission reactions, where atoms will be broken like it's an atomic bomb, leads to the atomic bomb. And other is collision technologies, where when two molecules collide, a large amount of energy will also emanate. So this facility is actually will be located in the France, with cooperation of more than 6 countries across the globe. India is also participate. So once this facility is fully operational, entire globe will not have any power shortage. So a lot of surplus electricity for the entire globe. So we also have the facility for anti-proton and ion research, which is also called as FAIR. So which will be established in Germany. We have 30-meter telescope. We also have international ocean drilling programs. As you know, we have India's own mega science facilities like Indian Moon Mission, and we have 3.6 Devastal optical telescope. We also have the Mars mission, and so on and so forth. People are also coming to our mega facilities also from across the globe. So this is where last year we visited with Secretary Professor Sharma, Sutosh Sharma, and this is at CERN Geneva, and it's a large hadron, large ion collider experiment, also called as ALICE. So in this mega science facility, more than 50 Indian students and faculty are making use of this facility with DST support. And this is where we have the DESI facility, where our Honorable Minister has, Dr. Harshvardhan, has actually inaugurated this, dedicated this facility to the national in the year 2016. And where this technical activation of 3.6 meter optical telescope was actually inaugurated by the Prime Minister Modi in cooperation with Belgium. And this is where we had signed memorandum of understanding on 31st March 2016 on LIGO when Honorable Prime Minister Modi visited US. We also want to bring the LIGO Gravitational Wave Observatory to India very soon. Government of India has actually approved the cost, and it will be, we'll have our own LIGO gravitational wave experiment. So this is as soon as the Prime Minister Modi visited Japan, which was his maiden visit to any foreign country after he became the Prime Minister of India, it was Japan. So when he visited Japan, we had actually organized his visit to a very famous laboratory on stem cell research. He met Professor Sinya Yamanaka, and he discussed with Yamanaka whether his stem cell research can tackle sickle cell anemia prevalent in some parts of the country. So he really encouraged all the scientific community in Japan as well as in our country when he visited. So as far as the brain drain, we are trying to transform brain drain to brain gain through a lot of scientific advancements and make more liberal scientific funding to the Indian students and faculty through various programs of DST. So I want to quote a reference of Elsevier publications where they have computed number of people going to the other countries and number of people coming to India, and they have found out there is about 0.6% of net brain inflow into the country. So that means India is now, it's no more a brain drain country. Now rather it is a brain gain country where people are actually trying to come back to India and work for the country. This is a very remarkable achievement by the government of India, where we are trying to actually transform the country from brain drain to brain gain. So again, I refer to one of the reports prepared by the Japan. So it says that Indians are very prominent and top in the fields of robotics, computers, and electronics device development. So not necessarily the Indians residing in India, but across the globe. So these are the three themes where Indians top across the globe. One is robotics, computer vision, and electronics device development. These are where the countries leading the world scientific publications. I'm glad to share this news that we are number 3 as far as total research publications is concerned after China and United States. This is all possible because of the very liberal funding for the scientific community by the Department of Science and Technology and other government of India departments. This also, India finds its place in number 4th, category 4, in terms of the number of doctoral students each country is producing. And for the last decade or so, there has been a lot of growth in the educational and R&D infrastructure in the country. We have about 740 universities in the country, and there are several government-supported universities and research labs. And then we also have about 23 IITs, 31 NITs, and we also have IIITs, International Institute of Information Technologies, and we have basic science institutes like we can actually link with the ICERs. It's a new set of institutes which are actually similar to the IITs. So IITs are meant for generating students and preparing them to take up the technology related courses like engineers. And as I mentioned, the basic goal of Inspire program is to bring the people to take up the basic research and education. So where these people will go? So Government of India therefore established the new set of institutes called ICERs, Indian Institute of Science and Education Researches, where we have about 9 ICERs now. These institutes will basically deal only with the basic research and education. So that means this outcome of these institutes will be students who are fully qualified in the basic sciences like physics, chemistry, mathematics, and earth sciences and biological sciences. So we also have other set of institutes, NIFRS, National Institute of Pharmaceutical Education and Research. So these are exclusively on pharmaceutical education in the country. And also we have very famous Indian Institute of Management. We have medical institutes similar to the All India Institute of Medical Science, Delhi. We have 7 plus more being established in the country. And as far as the global GDP trends are concerned, we have it's a prediction that by 2060, India will contribute to about 18% of the global GDP. And at present, it's India's contribution in global GDP is only 3.1%. But the way it is progressing by 2060, it's a prediction it will be more than 80%, 18% or so. And we also have the basic advantage is our scientific and trained manpower. Sometimes in the few decades back, our population growth was not very well appreciated. Now this is a kind of blessing in disguise where our India, the trained manpower, male as well as female, the entire globe is looking forward to receive our Indian students, our Indian faculty, and there are really trained people, and this is actually an advantageous position for India. It's trained manpower. And also, this is another important slide I would like to highlight. This is a global workforce shortage and avenues. When you consider all the red circles by 2020 onwards, so all the countries will have very negative kind of manpower in the age group of 15 to 59 years, whereas India has 47 million surplus trained manpower in the age group, working age group of 15 to 59 years. So this is again a plus point for India. Now I'm going to start my second part of the presentation, where I'll basically highlight what kind of avenues and opportunities that are available at the Government of India level to the students and faculty. Now, the history and advantages positions of India in the field of science and technology has just been presented, but now this is a very important part of the talk, and where a lot of opportunities available at this present time at the Department of Science and Technology. So when you consider the R&D infrastructure program, previously it was known as FIST program, Funds for Improvement of Science and Technology Infrastructure in Higher Education. We very liberally support the postgraduate to college support, university departments, where the science education is actually undertaken. For example, physics, chemistry, or even engineering, all the science departments, we support the teaching equipments as well as major research facilities to cater to the faculty and the students. This is a very important program as far as promoting and development of the infrastructure at the university level. But this will be only given to the university sector, not to the research institutes. For research institutes, there are other revenues that are available. And under this FIST program, there is another program called PURS, Promotion of University Research and Scientific Excellence. So this is given to the based on H index up to the tune of 30 crores, 15 crores, 9 crores, and so on and so forth. This is basically to establish major scientific facilities in the departments. This is given to the university as a whole. So it is up to the university which department it will establish a needy facility. And then this is, as I discussed in the before also, so impacting research, innovation and technology, which is called as Imprint. This is the first of its kind pan IIT program, supported by the Ministry of Human Resources and Development, initiative to address major engineering aspect activities in the country. And its goal is to address and enable, empower and embolden the nation for the self-reliance. So Department of Science and Technology is partnered with MSRD for implementation of its program. So at this moment, there are 5 to 6 IITs are given different challenges on the different themes. For example, healthcare technology, IIT Kharagpur is a nodal institute, and for computer technology, IIT Kharagpur again, and for advanced materials, IIT Kanpur, and water resources, IIT Kanpur again, for sustainable habitat, IIT Roorkee, and security and defense, IIT Madras, and manufacturing technology, IIT Madras, nano science and technology and hardware, IIT Bombay, and environment and climate, it is IISc Bangalore, energy security, again IIT Bombay. So it doesn't mean that these IITs are only given, but these IITs will act as a nodal institutes to promote this imprint program. So anybody can apply, all the IITs or all the universities and all central universities and institutes are allowed to apply and take advantage of this imprint program. And under the Department of Science and Technology, we have another important program called SAFES. So Sophisticated Analytical Instrument Facilities, where these facilities will be provided for the service of facilities of sophisticated analytical instruments, which is not possible to set up at a single institute. It will be established in the institute which is centrally located or regionally located, which can cater to the entire region, not necessarily to the one single institute. And we also have intensification of research in high priority areas. So this is actually centered around the expertise of a person rather than an institute. Suppose if one scientist has an expertise in operating a major scientific facility, he is trained abroad on certain facility, and that facility is not available in India. So under these conditions, so it will be the facility will be supported to the scientist, and for about 5 to 6 years. So beyond which the institute has to take care of its maintenance and operation. So this is what is called IRPA facility. And under the SCRB and DST also we have core research grant. So this is the kind of flagship program available from the government of India to for the research grants. Anybody can apply to this core research grant. This is for the scientific research. So this is funded through SCRB. Previously, it was used to be supported by SCRC in DST. And there is another scheme for funding industry relevant R&D. Its objective is to utilize expertise available at the academic institutions and laboratories to solve any industry specific problem to a larger benefit of the society. So this program is also available for the takeoff. For the mathematical research promotion also, we have a program called Matrix. So Matrix scheme is aimed to provide fixed grant support through active research in the field of mathematical sciences. We also support international travel support. For example, any student or faculty who want to participate in the international workshops and seminars and symposia, so DST will very liberally support. And for the younger students, it will even provide registration fee as well as full travel support, and even to the faculty. So this is please make use of such facilities to present your research outcomes in the international fora. So we also provide a lot of assistance to professional scientific bodies and for organizing the seminars and symposia at their institutes. This program provides a lot of partial financial support to the people who are organizing international conferences at all levels. We also have this is the recent initiative, startup research grants will be provided to the young scientists. Under this, there are two categories: early career research award and national postdoctoral fellowships. So the only difference between these two, if any young scientist is working in an institute who has already have a permanent position, for them the early career research awards are applicable, and people who do not have the job or regular positions will be eligible to apply for the national postdoctoral fellowship programs. So please look at the SCRP website for further details. So there is another scheme called Year of Science Chair Professorship, which was established in year 2012. It is recorded as Year of Science, YOS. So this is also a very important program. One can actually make use of this program. So SCRT Distinguished Fellowship Award is also basically to support research of superannuated eminent senior scientists who has real expertise in the research. So he can get this kind of program, and this is basically to make use of the research expertise available with the eminent scientists who are just retired. And there is a JC Bose Fellowship also. This is again very eminent fellowship. This will be initially will be given for 5 years, and if the fellowship the professor is superannuated also, fellowship can go up to 68 years of age. The fellowship amount will be rupees 25,000 per month, and he will be given a kind of research grant also per annum, and there are overhead expenses also are given. This is very competitive again. However, one can make use of such facility. So as I mentioned before, the Vajra Fellowship, Visiting Advanced Research Joint Research Fellowships Award, the Honorable Prime Minister of India during 14th Pravas Bharati Divas Convention has actually announced this program, and a large number of faculty are actually making use of this Vajra faculty positions. So Vajra faculty is actually provided a lump sum amount of US 15,000 in the first month, and then 10,000 per month in the other 2 months to cover their travel and honorarium, etc. So there is another fellowship called Ramanujan Fellowship. The fellowship is actually meant for brilliant Indian scientists and engineers from all over the globe to set up scientific research positions in India. That is for those Indian scientists who are actually working from abroad. The fellowships are scientist specific and very selective and very competitive also. One can try to make use of these fellowships. Basically, the idea of this Ramanujan Fellowship is to bring back our Indian talents who are actually working abroad. This is another important initiative recently we have taken, Distinguished Investigator Award. Suppose if one scientist or professor from university has already awarded any research project, and based on his performance in the project, he will be actually given additional support after completing the project. So therefore, he will be nominated as a Distinguished Investigator Award, provided all his rankings are outstanding for all the years of the project. We have the SCRC Overseas Postdoctoral Fellowship Program, so where the Indian scientists who have just completed the doctoral program can apply to anywhere, any institutes across the globe to work there as a postdoctoral fellowship. All his expenses will be actually provided by the DST, and a support of US dollars 3,000 per month will be given for his tenure. There are a lot of areas have been identified, including material science, energy, sustainable chemistry, and so on and so forth, which are actually listed here. But one can actually go through SCRB website for more further details. So there, in order to bring the woman into the mainstream research, a lot of woman-centric programs also to encourage the women to actually do a lot of research. SCRP Women Excellence Award is also given every year, and this is very simple. The woman scientist should be a member of one of these national academies: Indian National Science Academy, Indian Academy of Sciences, Indian National Academy of Sciences, Allahabad. Now their list is given, and she is a member of all these associations, scientific associations, and also have little number of publications. She is eligible to get the grants from SCRP. So there is another SCRP research scientist scheme. As I mentioned before, the Inspire faculty scheme is also supported by DST, but this will not be extended after stipulated tenure of the program. So for those people who have just completed the Inspire faculty scheme, and they can actually apply for SCRB research scientist scheme. So very attractive monthly remuneration will be given to the young scientists in the country. There are, in addition, we have Swarna Jayanti fellowships also to support and encourage the very young and talented Indian scientists who want to work in any of the Indian laboratories. There are details you can actually go through SCRB or DST websites. So as I mentioned, we have society-centric programs. This program is called SEED program, Science for Equity, Empowerment and Development. In order to promote the grassroots technology empowerment and sustainable livelihood at the grassroots levels, so the SEED has been established recently, and there are a lot of opportunities available for this empowerment and equity opportunity for excellence in science. There is again a very good program scheme called Funding for High Risk and High Reward Research. For example, Government of India, DST, wants to take a risk. Suppose if any student or scientist have a very brilliant idea, which the committee feels that this will be supported by taking a risk, it may result in good product or may not. That's why it is a high risk. If the result is good, it's a kind of high reward for the researcher as well as to the country. So that's why it's a high risk, high reward, where the country wants to take a risk of supporting a young scientist, even though the result is not known. So this is very recent initiative by Government of India. One can tap this opportunity also. There is another scheme recently, Avasar scheme, augmenting writing skills for articulating research. So basically, the young doctoral students who have just completed the PhD will have more tendency to write the thesis and scientific research papers, etc. However, we want to improve his skills for writing articles or stories which are actually understood by the common public. So this is the Avasar scheme is meant to transform the scientific research which are actually make make it understood by the common man. For this project, we want to support a large number of PhD students who actually can avail these facilities after completing their PhDs and write the stories which will be published in the journals as well as magazines. And also he will be given awards, very attractive awards up to the cash prize of 1 lakh to 50,000 and 25,000 also. Thank you very much for all your patience. And I'm ready to take up any kind of questions if you have. Are you there?
Yes, sir. Yes, sir, we are there.
Yeah.
So thank you so much. And, despite the little technical glitch, we thoroughly enjoyed the session, sir. And it really brought to us some very exciting opportunities in this Indian ecosystem of science and technology. Thank you so much, sir, for sharing this, because this is very
Okay.
internal information that we got to know. As far as my personal experience is concerned, and I'm sure many of the careers will take a new thinking after understanding this entire workflow.
Right.
So it's really amazing, sir. Thank you so much for joining in and taking the valuable time for us. Now, I would request Professor Dipali Virmani, our HOD CSC, to kindly give away the vote of thanks. Over to
Okay.
you, ma'am.
Yeah, thank you, Sharu. Thank you, sir. Thanks a lot. The speech, the talk that you have given us, sir, we have came to know about many insights. The things, the projects the government of India is doing, the awards, the funds they are giving. Really, we were unaware of these opportunities. Thank you, sir. So, on the behalf of the Department of Computer Science and Engineering, BPIT, and Fossil BPIT, I am highly obliged to Dr. Shivaji for sparing few moments from his busy schedule.
Thank you so much for giving me this opportunity to interact with all the students and faculty. And let us
So
see in future.
we are highly obliged that you have enlightened us with your knowledgeable words. So through this talk, we have learned a lot about the Indian universities and growth of India in various aspects. Yes,
Okay.
sir, it's absolutely true. We also agree with the words of Pandit Jawaharlal Nehru, future belongs with science. Department of CSC BPIT is also working with this motto. Here we give a large emphasis on research and on good publications. Me, along with my faculty members and students, are always trying to do something new for the benefits of humans and societal benefits. So it's really an honor to be an eminent professor like you.
Thank you.
So
Thank you
it
so
would
much.
be privilege for us if we get to work on some project under your guidance. I'm always ready to work on research projects. We will like to carry forward this collaboration with you and would try to apply for any scheme and be the part of the growth of our country. So through your talk, we have came to know about a lot of missions and the schemes of DST. I would like to contribute to DST, rather our government, for all these initiatives.
Right.
Sir, I would also like to share that recently we have applied for SEED, project you were telling under SEED. We have applied for one of the projects for visually impaired. Yet it is under review process. It's going on. Last year we have applied for it from BPIT.
Nice. Yeah.
Sir, I would also like to thank the management of BPIT for allowing me to organize this event. I am indebted to our principal, Professor Payal Pawa, for always motivating me to take up the new challenges and organizing the webinars for the benefit of teaching and non-teaching fraternity.
Right.
My deep sense of acknowledgement to all the directors, deans, HODs, OSD, teaching and non-teaching staff members of BPIT. I'm also highly thankful to IC FOSS to establish FOSS Cell at BPIT and initiate this webinar series. So special thanks to the members of the organizing committee and the creative committee. Last but not the least, my heartfelt thanks for all the participants for being such a patient participants. Again, sir, thanks a lot for your valuable time. Really, we enjoyed the talk, and I am speechless to say about the missions and the initiatives my country is taking. And I would love to be part of any of the mission if I can contribute as being the researcher in this area, science and technology.
Sure. Yeah. Yeah.
Thank
Thank you
you,
so
sir.
much.
Thanks a lot for your time. Thank you.
Yeah. Sure. Thanks.
Dr. Bhavna, you can share the feedback in the chat window so that the participants can fill the feedback and they can get the certificates.
Ma'am, it's already shared.
Okay.